Hello friends, welcome back to my channel Engineering Mathematics djganit. From this lecture onwards, we are going to discuss about functions. This is one important topic in discrete mathematics. So we will define what is function and we will discuss some concepts or definitions related to functions. We are already familiar with the concept of function from our school classes. So to define a function, we require two sets. Suppose I have two non-empty sets, set A and B. Then function is a relation between two non-empty sets such that for every element in this set, there is unique element of this set assigned by some rule. So we can say that a function is a rule or relation which assigns unique element from set B to every element of this set A. Every element of one set must be assigned to unique element of another set by some rule or some relation, and that type of relation is known as function. We can understand by taking particular sets. Suppose I consider in one set, I consider these three districts. Suppose I consider here in set A, I consider three districts: Arvalli, Banaskantha, and say Sabarkantha. So set A contains name of these three districts, and in set B we consider capital cities or capital towns of districts. So here suppose I consider here Palanpur, then here I consider Himmatnagar, then Rajkot and Modasa. So I have taken two sets. In one set I have taken three districts. In another set I have taken four different towns or cities. Now we want to define a function from set A to set B. So we consider this type of relation, that if I consider an element of this set A, then I assign the element from set B to this element by this relationship. So we consider this type of relation. We are interested in the capital city or capital town of a district. So we define this relationship, capital city of a district. So under this relationship we can assign element from set B to every element of set A. So if we consider Arvalli, then we know that capital town or capital city of Arvalli district is Modasa. So Arvalli will be assigned Modasa from this set. Then we consider Banaskantha. So capital town of Banaskantha is Palanpur. So Banaskantha is assigned this Palanpur city. Then Sabarkantha is assigned Himmatnagar. Himmatnagar is the capital town of Sabarkantha district. So we can see under this rule or this relation, we have assigned unique element of set B to every element of set A. So therefore this relation is a function from set A to set B. Now suppose I have Surat here, then there is no element which we can assign from set B. So that will not define a function from set A to B if we consider this Surat district in set A, because there is no element from set B which we can assign to this Surat district. So if I enter this element Surat, then I will not get a function from A to B, or this relation will not define a function from A to B. So I am removing this. So every element of set A must be assigned unique element from set B. It is not necessary that every element of B must be assigned or must be related to every element of A. Here we can see we have these three elements which are related to elements of set A, but this Rajkot city is not related to any element of A, so don't worry about that part. But every element of this set must be assigned to unique element of set B. So this capital city of a district defines a function from set A to set B, and that we can denote by this type of notation. F is a function from A to B. In another words, we can say that function f maps set A to set B. We can also say that f is a transformation from set A to B. These are the different synonyms for the function. We can say that f is a mapping also. So functions, transformation, mappings, all these words are synonyms. So this is meaning of function. Function is a rule or relation between two sets such that every element of set A is assigned unique element from set B. So if f is a function from set A to set B, then this set A is called domain of the function and set B is known as codomain of the function. Suppose I consider x in set A, then suppose unique element which is assigned to x from set B is y, then we can say that y is the image of this element x, image of x under function f, and this we can write as y equal to fx. When I write y equal to fx, that means y is the image of x under function, or we can say that y is the value of the function at point x, value of the function at point x. So these are the different synonyms. We can say that y is the image, or we can say that y is the value of the function at x. This x is called pre-image of y. X is known as pre-image of y, and another word for x is argument. We can say that x is the argument and we assign this image y to this argument. Another definition is range of a function. So range of a function is equal to the set of all images. The set of all images of elements of domain is called range of the function. So in this example we can see the images are this Palanpur, Himmatnagar and Modasa. So range of this function, which is denoted by r suffix f, will contain these three cities: Palanpur, Himmatnagar and Modasa. Rajkot is not the image of any element of set A, so Rajkot is not in the range of f, and this set B is the codomain of this function. So range of f is always a subset of codomain of f. Domain of f can be denoted by d suffix f. So it is not necessary that sets which we will consider to define a function will be finite sets only. Here sets A and B are finite, but we can have infinite sets also, and we can define a function from infinite set to infinite set. Suppose we consider this set of integers denoted by z, then we define fx equal to x plus 1, x belongs to z. Then we can see that f is a function from z to z, and if we consider here on this side set of integers, on this side set of integers, then for every integer we assign unique element denoted by y equal to x plus 1. For example, if I consider x equal to 0, then image will be 0 plus 1, that is 1. If I consider x equal to 1, I will have minus 1 plus 1, that is 0. So image of 1 is 0, image of 0 is 1, image of say 30 is 30 plus 1, that is 31. So this is a function from infinite set to infinite set. Suppose I consider another function from say set of real numbers to set of real numbers denoted by given by fx equal to x square. Then this is also a function from R to R. We can assign to every real number its square. So we can square every real number. So for every real number there is a square of that real number which is in codomain, and that square is unique. Here for example, suppose I consider f of minus 2, then I will get 4. So I will obtain unique element, or square of a real number is unique. So this function defined by fx equal to x square assigns unique element from this codomain to every element of this domain. Therefore it is a function from R to R. Now if I consider f from R to R defined as fx equal to 1 by x, then if you observe that suppose I consider x equal to 2, image of 2 will be 1 by 2. Similarly image of 3 will be 1 by 3. But if I consider x equal to 0, I will obtain 1 by 0, and that is going to infinity. So it is not a finite real number. So we can say that for x equal to 0, there is no element in the codomain, or x equal to 0 cannot be assigned to any element from this set. So this is not a function from R to R. Suppose I want to make this f a function, then I have to remove 0 from this set. So I have to change my domain. I have to consider my domain as R minus 0, set of all non-zero real numbers. So if we consider fx equal to 1 by x from R to R, then f is not a function. But if we consider f from R minus 0 to R, then this will define a function. So it is very important to understand all these concepts: domain, codomain, range of a function, how we can decide that whether given formula defines a function or not. So I have written all these things systematically here. First we have written the definition of function. Let a and b be any two sets. A function f from a to b is a rule or relation which assigns unique element of b to each element of a. If y is the image of x, we will write fx equal to y. If f is a function from a to b, we use this notation to denote that f is a function from a to b. Sometimes this notation is also used. A is mapped to b via function f. So functions are specified in many different ways. Sometimes we explicitly state the assignments as shown in figure below. So this is one way of defining a function. I have taken two sets. In one set I have this name of students, and on another side we have grades of students they have obtained in the assignments of discrete mathematics class. So this student Vijay is assigned A grade, Rusi is assigned C grade, Hina is assigned B grade, this Dhyani is assigned A grade, and Meet is assigned F grade. So this is one way of defining a function or representing a function. If we have finite sets, then we can define function in this way also, or represent function in this way. Another way is we can write the formula of the function. For example, fx equal to x square. These are the different synonyms used for same word function. We can call function as transformation, map or mapping. Correspondence is also another word for the function. Operation is also used as synonyms of functions. Then I have defined all these things. If f is a function from a to b, then this a is called domain of f, b is called the codomain. If fx equal to y, then x is called the argument, and corresponding y is called the image of x under f. Y is also known as the value of the function f at x. Then range is the set of all images of elements of domain is the range. Range of function is always a subset of codomain. We can write range of f mathematically in this way. If f is a function from a to b, then range of f is the set of all elements of codomain which are images of elements of A. So if y is in the range of f, then there must exist some element x in domain A such that y equal to fx, and domain of f is denoted by d suffix f. If f is a function from a to b, we say that f maps set A to set B. Here I have taken set A, set B, x is the element of A, and we assign y to the element x under this function f, and we denote it by y equal to fx. Y is the value of the function at point x, or y is the image of x under this function f. This is another example of function. Here I have taken domain and codomain as the set of integers, and I consider this formula to define a function. So here domain of function is set of integers, codomain is also set of integers. Range of f equal to, we consider those values in the codomain such that there exists x in domain such that y equal to fx and fx is x square. That means range of f will be square of integers x square such that x belongs to z. For x equal to 0, its square is 0. For x equal to 1, it is 1. For x equal to 2, 4, and so on. So we obtain infinite set here, which is containing squares of integers. This is another way of writing y equal to fx. Y equal to fx we can write in this way also. Okay, we are using this type of notation, x y belongs to f. We will study this type of notation when we will start discussing the topic of relations, which is also an important topic of discrete mathematics. So in that chapter or in that topic we will be using this notation. So we will discuss in detail about this type of notations in that topic of relations. So in this lecture we have defined what is meaning of function. We have introduced different terminology, domain of function, codomain of function, range of function, and we have seen some examples of functions. In upcoming lectures, we will be continuing with this topic function, and we will discuss some more definitions which are in this topic. So this is all about this session. I hope you like it. Thank you.